What?
That'll work.
That'll work, Gwennap? Okay, he's the chief engineer at Raytheon, air vehicle, UAV mission control stations. He was a founding member of the UAV control station working group, which developed the UCS architecture, which is now an SAE standard. He builds complex architectures to solve complicated problems for customers across DoD. He has been working for Raytheon as a software and systems engineer for over 21 years. You're just a baby. Including 16 on UAV programs. He graduated from Carnegie Mellon University with BS in Cognitive and Computer Science and completed an MS in Software Systems Engineering at George Mason University. He has 2 children in college and loves photography, which is why he is poor. And with that, I turn it over to you. Oh.
Yeah, I'll bring my own slides up because I know how to use Windows.
Okay. Good. I'm going to sit back down so I can see your slides.
Okay. So we're going to talk how we use DDS in control stations that we build at Raytheon. So we're going to talk about the advantages that DDS Discovery gives us, how PubSub enables the architecture that we've built, how we use partitions and domains as part of our architecture, and then we'll talk about how we're looking to incorporate at this point DDS Secure. So figured I would start with a little overview of exactly what the domain that we're looking to architect here with DDS. So the main thing that where I feel DDS gives us advantage is right now we're working on a Navy program called the Common Control Station, and the Common Control Station is now just been given a mandate to control every UAV, USV, and UUV in the Navy. So
Provide the acronyms.
So unmanned air vehicle, unmanned surface vehicle, and unmanned underwater vehicle, right? So ships, subs, and airplanes. So we need a flexible architecture that gives us the ability to start the right capabilities for each vehicle. So when we talk about UAVs, probably the most common thing that should come into your mind is predators, right? They're in the news all the time. Raytheon has nothing to do with the Predator, but it's probably the one you guys are most familiar with. So we control Global Hawk, which is a UAV with the wingspan of a 747. So we're talking large vehicles. We control Fire Scout, which is a helicopter based on a manned. There's 2 versions based on a manned aircraft. So the smaller one is based on a 2-seater, and the bigger one's based on more of a 4-seater size vehicle. So again, big aircraft. So we talked for a second about the UCS architecture. You were talking about the idea of coming up with common data models for things. So typically, most of the standards that existed before the UCS architecture were created were standards that provided interfaces along the outside of the control station. What UCS came along and did is divided the control station into a set of about 150 services, each of which perform specific capabilities, and then defined the interface for every one of those services as a set of messages. So we have a data model. And now everybody who implements the UCS architecture is implementing that same data model, and we have the ability to plug and play services.
Is that standardized?
Yes, it's now become an SAE standard within the last couple of years. That's where we discovered DDS. RTI was a major contributor to the UCS standard. And that's what really when we started implementing DDS into all of our control stations. So the interesting part is, I said, there's like 150 of these services within the control station. Some of those services are designed to be common. Some of those services are actually designed to be unique. At some point, we have to leave our data model and figure out how to talk to the air vehicle. And all the air vehicles don't have common or don't follow common standards with how you talk to them. They're trying to resolve that, but there's still, excuse me, there's still a lot of variability between the various standards. So some of the services are common, and some vehicles use all of them, and then we have others that are unique, and it just depends. A good example of that would be we have a service called Higgy Hoagie, which is hover in ground effects and hover out of ground effects. So it really computes whether you can hover your helicopter given the current environment, temperature, and so air density plays a big factor into whether you can make a helicopter hover. So obviously, if we're controlling a fixed wing aircraft, there's really no reason to put the Higgy Hoagie service running in the system. So the first thing we'll talk about is discovery. And as we've talked about, right, we have two different vehicles here. One vehicle's using service A and B, the other one's using A and C. What discovery gives us the ability to do is when all of those services come up, it doesn't matter what set of services we start, they all just use DDS discovery, they find each other, they set up communications with each other. So it gives us a very flexible way to start the system up and allow everything to find and communicate with each other. So it gives us a lot of flexibility in, as we move from vehicle to vehicle, how the system starts up. And eventually we want to get to the point where we have a single system that can control all of those vehicles. So it doesn't matter what vehicle today I want to use, right? I just go to the same system. So at any moment within the software, we could be controlling a Fire Scout or another vehicle is Stingray, right? So we could be controlling, Fire Scout in 1 minute, Stingray in another minute. We might be doing both of them together. So Discovery gives us the ability to get all of those things started, have them all find each other, and all start talking to each other. So the next piece is the pub sub. So what we do in our system is, because again of all the various configurations, right, all of our services are aware of the topics that they subscribe to, they're aware of the topics they talk to, and they're aware of nothing else. So what that allows us to do is when the system starts up, everybody connects to the right things, but it doesn't matter, if one service, one vehicle uses service A and B, they can still both be using the same topic, right? So B and C could be the same service, but different variants, or they could be different services. But again, because of the pub sub, we don't have fixed communications paths in the system. It makes it very easy to change the system. It makes it very easy to be able to start different sets of services on the fly and have all of those things talk to each other. As a matter of fact, we use DDS to be more facing towards the vehicle because of its real-time capabilities. We're looking at using web services to talk to all of the external web of things that we'll eventually need to talk to. One of the advantages of pub sub is we've been looking at using JBoss and using JMS, which is also pub sub. I can put a bridge in between the two of them. I can publish something on JMS and send it through the bridge, and the end result is that a DDS topic picks it up and some service gets data, and it doesn't care whether that's data coming from a JMS service or coming from a DDS service, or how that data is being passed around the system. I can take a DDS service and make it a JMS service, and everybody still finds each other and has the ability to talk to each other.
So if you're going from DDS to JMS, what is the format of the messages that goes through? Like JSON, or is it?
I'm not sure exactly how our guys did that translation, but we're using all UCS defined messages. So so on DDS, we basically have the IDL, right? So we're just figuring out how to do an IDL to XML translation, right? And then push it through.
Through XML, okay.
So for partitions, so as we talked earlier, right, I may be flying two vehicles at the same time, right? So we had to figure out how to do that in a simple way. So what we've done is we can start the same set of services for two separate vehicles. We start them in separate partitions, and then after discovery, right, they only know about their own partition, and that means all the services for one vehicle are confined to their own partition and talk amongst themselves. So I can have the same services and topics running in both partitions, and I don't have any interference between all of those services.
Lance, are those like OS partitions? Are those like virtualized memory areas? Is that what
They're DDS partitions.
right?
They are DDS partitions. Yeah, sorry I didn't make that clear. All this is DDS. So yeah, so there are DDS partitions that are providing us those capabilities. So the next piece. So we use the DDS domain concept to handle non-flight critical versus flight critical data. So especially for air vehicles, all the portions of the system that actually control what I call the tin can in the sky, right? Those are all flight critical. And we get standards applied to us sometimes to the level of the same standards that the FAA applies to manned aircraft. So there's I don't know if people are familiar with DO 178, but it's the FAA standard for safety. So the Navy has their own standard for safety. But what that does is there are very stringent processes that you have to go through to generate that software to show that that software is safe, and you have to create a whole enormous load of documentation that proves that you've done all of those processes to show that your software is safe. If you put all that software together where it can all talk to each other, then it doesn't matter that you have non-flight critical software. Their answer is it all has to be safe because it's all together. And that makes all your non-flight critical software expensive to develop because you're doing all these safety standards. So the solution that we've come up with now is we're going to run all the flight critical software in a separate DDS domain from the non-flight critical software. That eliminates the ability for those two pieces of software to talk to each other. So in a DDS domain, right, when you do discovery, the only thing that can be discovered within inside of the domain is stuff within the domain, right? So it's a different port, each domain. So if you have software in one domain, it can't talk to software in the other domain unless you specifically put a bridge in place that attaches to both domains. So our idea will be that we'll have everything running in two domains. We put a bridge between that reads from specific topics on one side and passes the data to the other side. And in particular, the issue is, when the non-flight critical side is trying to send data into the flight critical side, we want to limit what they're allowed to send in, and we want to validate that data to make sure that it's not corrupt or somebody's not doing something bad that will result in the software in the flight critical domain doing something bad.
So the classification here is critical versus non-critical. There's no secret different types of clearances or anything, all running in the same level.
Yeah, typically, for the moment, we've run most of our stuff all at the same classification level. That may change in the future. It's really controlling the vehicle is not really classified. Most of what makes the systems classified is once they start collecting data. A lot of the data can be classified, and it can be classified at different levels depending on the type of data that's being collected. At the moment, we just run it one. But there's constantly talk about MLS and having to deal with that. But for the moment, we're not. So,
I'm sorry.
Go ahead.
Has this use of different domains for flight critical versus non-flight critical passed muster for the certification requirements?
yes.
Excellent.
So, so there's a vehicle steering command, for example, and it has a lot of things in it, but one of the basic things in it has is altitude, airspeed, and heading, right? So that controls where your aircraft is going. We don't want the non-flight critical domain to send that message to the air vehicle, right? Because it may not go through all the rigor and structure and whatever that we put in place to prevent bad messages from getting to the vehicle. So the bridge would not allow a vehicle steering message to cross into flight critical. So that's an example of something that we would prohibit. Most of our vehicles today follow a mission plan, and that mission plan is just a set of waypoints, and we load that to the vehicle. Well, we don't do the mission planning in the flight critical domain. So at some point, we have to send the mission plan created in the non-flight critical domain into the flight critical domain, right? So that's something we want to pass through, right? So, excuse me. The bridge gives us the capabilities to limit what goes through and what doesn't. And then from the flight critical domain, there's lots of vehicle status that the mission side might need to know. All of that stuff flows freely through the bridge because there's not a problem with things going from the flight critical to the non-flight critical.
So, Lance?
Yeah.
Do you think a combination of partitioning and domains, you could come up with a multi-node secure solution and possibly use a bridge as a downgrader?
That would certainly be something I would initially look at as a way to handle it if we get hit with those requirements. Yeah. So it would depend on the rigor that was required to move things, right? Because we can make a bridge that looks a lot like a guard, but the end answer may be that it is a guard, right? But yeah, certainly those are things that would help us partition and divide up the system and be able to protect those various pieces. But yeah, it does get fun and tricky because we talked about earlier about flying multi-vehicles, right? So if I'm flying, 3 different vehicles, I could have 3 different partitions in here for the flight critical for each of those 3 vehicles, and I could have 3 partitions over here for the non-flight critical part of each of those 3 vehicles. Right, so the domains and partitions are already fairly complex. So the last component is DDS secure. So this is something that we're beginning to implement in our systems right now. So those domains are great. They divide everything up. We put our bridge. Everybody behaves correctly. Life is good, right? But we all know that bad actors don't behave well, right? So even though I've set up this flight critical domain and put this bridge in place that limits the traffic, right? Somebody who's not supposed to could come and join my flight critical domain and all of a sudden start putting things on it that we don't want on it. The idea will be is that once we have everything divided, then we can implement DDS secure. We're going to then be able to say only these services that are flight critical services and only the ones that we've built, right, are allowed to connect to the flight critical domain, and that would prevent anybody who's trying to tag along who shouldn't be from connecting to that domain. And the way DDS secure works, right, is you have to be authorized to be on the domain, you'll have to be authorized to be on the partition, and once you're on there, then you have to be authorized to talk to the specific topics, right? So we can have pretty fine-grained control over each service and who's allowed to talk to each service and who's allowed to write to the various topics.
So you have implemented this, or you were looking at implementing this?
So we have a task from our customer to implement this. We've just begun the process. We're about to do an architecture study in order to determine that we have the right implementation. I think within the next week, we're going to start building a prototype to try and understand exactly what the impact of using DDS Secure will have overall on the system. So the last bullet, right, we're going to have to encrypt all of the data as part of our safety requirements. As data passes from service to service, it will get encrypted and unencrypted. So we need to look and understand what the impact will be on the system from a performance perspective. The other thing that we're concerned about is that when you start up a system with DDS Secure, every service has to go get its keys. And then when you do discovery and all the services are talking to each other to identify whether they should be talking to each other, now all of a sudden they're trading those keys so that they can actually communicate to each other. We have concerns of what the performance is going to be during that startup phase and how much that will impact the duration of the startup phase. So we have very strict requirements on how long it takes to start up the system. One of the problems can be is if the system fails where you have a vehicle in the air, you have to reboot the system, and you don't want that vehicle flying uncommanded for longer than it needs to be. Although,
when you talk about architecture, how are you doing those architectures? Are you doing modeling of the architectures, or you said you?
So the first thing we have to sit down and do is understand exactly what rule sets we're going to need to put into DDS Secure to implement the various levels of security that we need to. We're using RTI's DDS Secure, and we're not familiar with that product yet, so we're getting RTI is helping us getting an understanding of exactly how we'll configure the product and what rules we'll need to set up and how to configure each topic and all of those things. And we want to design that out thoroughly beforehand. Even if we...
So when you're doing the design, I guess my point was, what are you using to design with? UMLs,